would like to discuss about the memory hierarchy in computer organization. We know that the memory is an essential component to store programs, instructions, everything within the computer. We simply classify this memory in two types. One is the primary memory and another one is the secondary memory. There are several types of the memories we will discuss later. So, what do you mean by the primary memory? The primary memory, in the primary memory, the processor, the heart of the system, the processor can directly access, can always identifies this one only. That is the primary memory only. And the secondary memory, where we are going to be store the programs and the instructions on permanent basis. This is known as the secondary memory. Here also one thing, the primary memory is again divided into the two categories. One is the random access memory and another one is the read only memory ROM. Here you can take one caution, one precaution. Number of people says that ROM is the secondary memory. It is not right. ROM is also the primary memory, but it is supplied by the hardware manufacturer or the system builder actually who has certain programs. These programs are known as the bootstrap programs or simply boot up programs to start the computer. The programs are designed by the manufacturer and sealed within the memory and supplied actually. So without this memory it is not possible we are going to be start the system. Hence, we are also be consider the ROM is also a primary memory. And another one is the to store the programs and that is the auxiliary memory or secondary memory. So how we are going to be classify the memories means generally here in the below part I am going to be discuss. There are several memories. Here we are going to observe that actually magnetic tapes, magnetic disks, actually, and main memory that is the random access memory or ROM, cache memory, and registers. Generally, the registers are we know that the registers are within the processor, right, to store very little data and presently executing uh, data or instructions are within these registers. The registers also be existed within the process, right? The storage capacity of the registers is very less actually, but the speed of accessing by the processor because those are within the processor itself. Hence, the accessing speed of the registers is very high. And one more memory that is known as the cache memory. Here I am going to be represent this one, the cache memory. Actually, the cache memory is placed in between the RAM. That means main memory, cache memory, and the processor. Here also we are going to be considered like that. So main memory and cache memory. Suppose anything is fetched from the secondary storage. These two are the secondary storage, right? Here I am going to call it as a secondary storage unit. That means hard disk, magnetic tapes and the drives and the CDs and something else. From secondary storage, the by using the IO processor, input output processors, the data is transferred to the main memory. From main memory, during the transmission at the first time, during the transmission of the data to the processor, one copy of information or the data is stored within the cache memory and then CPU. Suppose the processor should not find the data or instruction within the cache memory, then only it go to the main memory. So when we are going to be discussing the capacities, we are going to observe this diagram, right? The top is the registers and the next one is the cache memory, the next one is the main memory, and the next one is the magnetic disk and magnetic tapes. So from top to bottom, from top to bottom, there the capacity of the storage capacity is increases. At the same time, that means register store very less, cache memory a little bit high, main memory. something high. Magnetic tapes and magnetic disks actually store the huge volumes of the data. So, and again, in the same way, we are going to go from the bottom to top. Actually, the speed of accessing is already increases. So, I am going to write the same thing. Refer to total volume of the data system memory can store capacity, access time, and performance. So, we are going to be divide the characteristics of the memory. The R features of the memory is the capacity, how much data it is able to store, right? How fastly it can access the and their performance. That means with hierarchy and cost of the bit. These are the things I am going to be defined as the line. So what are the registers? Registers are generally within the processor. There are we all know that the registers are again divided into the two types. One is the general purpose registers that are represented with R1, R2, and like that. And someone is the special purpose registers where know that is the accumulator, address register, program counter, and these are the registers. Actually, here we store the data and instructions in general purpose registers. Special purpose registers are used for the specific operations. And the cache memory, I just say to you, that is placed between the RAM and primary memory and between the processor. Most frequently used information, because suppose let we consider this is the processor and this is the random access memory. Suppose I'm going to be write an instruction, for example, while a less than 10. Here a value consider 1, a equal to a plus 1. So a is fetched by the processor and I add 1. Now a value is 2, again stored back. After that again the condition is true. Again the a value is fetched and again stored back, a value fetched and stored back. So most of the time processor time is wasted during the data transfer. To avoid this one, we keep the most frequently used data either within the registers or within the cache memory. So this cache is also be again two types. One is the L1 cache and another one is the L2 cache. The next one is the main memory or RAM. Actually, the primary memory, just I am going to be describe you. Just the processor can only identify the primary memory. Actually, the RAM structure is like that. So the RAM is like a the set of locations, and each location has the number, right? That is 1 2 3 something. This is known as the address to identify each location. Here what is the good thing is in the processor to access either the first location or 1000 location, the processor can take the same time. That means unique interval of the time. Suppose to get the data or to store the data from first location, suppose the processor takes the 2 seconds. The same way, suppose we are going to be access from 1000 location or 10,000 location or 1 lakh location, either to store or to access the data, the processor can take only 2 seconds of the time. The remaining, so what we are going to be called CD drives, pen drives, and external hard disks and hard disk drives and memory cards and everything. These are the known as the secondary memory. They can store the data on permanent basis. Okay friends, this is a very simple topic and very simple video on the memory hierarchy. I hope you can understand this thing. Thank you.